Okay guys, we're going to continue on with chapter 7 today. We're going to learn a new skill. This one involves using the roadmap. So if you're watching the video, please have your roadmap out, which is this diagram on this slide, a calculator, and your guided notes, okay? But today, the skill that we're going to focus on today is going from moles on the roadmap over to mass, which is really the number of grams of that chemical. So it's very similar to what we did last time, so hopefully you'll catch on very quickly. But say, for example, we're in moles. Okay, so here you are. How do you get 2 grams? Well, you got to follow the roadmap. Which bridge should I take, the top one or the bottom one? You're going to take the top one, so you're going to come across here. That means you're going to use this conversion factor, right? So you take whatever number of moles they gave you, times it by this conversion factor, and it gives you grams. Now, what do you notice about the conversion factor that's different? It's molar mass. Yeah, we still have 1 mole on the bottom, but what's molar mass? And so that's really what we've got to learn today. And that's what this lesson's going to be about. Okay, is using molar mass. And obviously we've got to be able to know what molar mass is, because even to get to grams to moles, so we go on this one, we still use molar mass. So let's get into it. First of all, molar mass, you're supposed to write down the definition in your guided notes. So molar mass is the mass in grams of 1 mole of any pure substance. So it is the mass in grams of 1 mole of any pure substance. Okay, so if you have 1 mole, it's the number of grams of that substance. The molar mass of each element is given on the periodic table. So that's another paper I would like you to have out and available. Is your periodic table. We're going to use it all day. I've got a little diagram of it down here in the corner that I'll keep down here, but I know it's probably too small for you to read the small numbers. So please have your own periodic table out, because you're going to need it. Okay, let's just stop for a second. It says that the molar mass of each element is given on the periodic table. So if I say hydrogen, what's the molar mass of hydrogen? Well, we know where hydrogen is. It's right here. But I want you to read this number. It's written right here, and you can't see it on this. 1.00795. Okay? That number is known as its atomic weight or atomic mass. That is the mass of 1 mole of that substance. That's its molar mass. So if you had 1 mole of hydrogen and you put it on the scale over there, what would it say? 1.00795 what? Grams. Okay? So 1 mole, so you have to have 6.02 times 10 to the 23rd hydrogen atoms would weigh 1 gram. I mean, that's a lot of atoms, right? Only has the mass of 1 gram. What if let's keep going with this. What if I asked you carbon's molar mass? What would you say? 12.0, let's see, 01 something? 12.01 something. What does that mean? 12.01 what? Grams. How much carbon would you have to have for it to weigh 12 grams? 1 mole. Which is 6.02 times 10 to the 23rd atoms of carbon would weigh 12 grams. Are all of the elements on the periodic table have a different molar mass then? They do. Let's just try one more. What if I asked you the molar mass of copper? Copper. 63.5. Good. If you look it up, 63.546. 63.546 what? Grams. Okay, so if you had 1 mole of copper, it would weigh 63.546 grams. And again, you would need 6.02 times 10 to the 23rd atoms of copper for it to weigh that much, because that's what 1 mole is, right? So they're all different. Okay, we just learned how to find molar mass. Well, what if I ask you to find the molar mass of, say, H2O? Well, that's what this bullet is for. It says to find the molar mass of a compound or a molecule, you simply add up the molar mass of each element in the compound or molecule. So Zach, help me out. If we're talking about H2O, what's the molar mass of that molecule? You simply add up all of the different elements in that molecule.
But I can't, like, if there's the 2 hydrogens, so I add those. So
Yeah, and let's just round. I know you guys are just loading this, so we're going to round to the nearest whole number. What does 1.007 round to? 1. So hydrogen is equal to 1. But how many hydrogens do we have, Zach?
2.
2. So let's times it by 2. So there's 2 grams from the hydrogen. But then there's also oxygen. What's its molar mass? 16. So oxygen is equal to 16. And I just have 1 oxygen, so I'm timesing it by 1. So there's 16. So what's the total molar mass for water? 18 grams. So the molar mass for water, 18 grams. So if you took a beaker of water over to the scale and I said get 1 mole of water, how many grams would you have to measure out? 18 grams. You would put water in that beaker until you got up to 18 grams. That's exactly 1 mole of water. Does that make sense? Pretty easy, right? Just add it up for a compound or a molecule. Okay. So practice problem number 9. Did you guys write that in your guided notes? Did you have to write that in? Yeah. Practice problem number 9. Actually, it's right here. Okay. Calculate the molar mass of water. We just did it. Hydrogen, if you look it up right here, is equal to 1. We're rounding to the nearest whole number. But we have to times it by what, guys? 2, and that gives us 2. Oxygen, if you look it up, it's right here. It says 16, if you round it to the nearest whole number. There's just 1 oxygen atom here, so times it by 1. That's 16. Add it together in the end. That's 18 grams. Okay. So there we go. Let's go to another practice problem now. Number 10. It says calculate the molar mass of carbon dioxide. I want you guys to try this one. Try it on your own and see if you can get it. Okay? Again, if you're watching the video, just simply add them up. And so hit pause and try it on your own first. Okay, guys, let's see how you did. So we've got CO2. So hopefully you looked up carbon, this number that's right here, which is rounded to the nearest whole number is 12. So carbon is equal to 12. How many carbon atoms do we have, guys? Just 1. So I'm going to times it by 1, which is 12. Oxygen. If you look it up, its number is right here. It rounds to 16. But how many oxygens do we have, guys? 2. So let's times that number by 2. That's 32, right? And then you have to add them together. So what does that come out to be? 44 grams. So 44 grams is the molar mass for carbon dioxide. How many of you guys got that? Good. Okay, good job. So I have this presentation all fancy, but we don't really need to do it. Okay, what this means is, and I think you have to write something in your notes here. What this means is that 1 mole of CO2 is 6.02 times 10 to the 23rd molecules of CO2, has the mass of 44 grams. So you would need Avogadro's number of molecules in order to get 44 grams of CO2. Okay, extra practice. Let's do this. It says find the molar mass of each compound. Let me put them all up here. So is there 5 of them? Yeah. What I would like you to do is take some time now and solve these on your own. Okay, if you're watching the video, please hit pause. Tell me the molar mass of each one of these, 1 through 5. And then once you have your answer, then hit play and see if you got it right. Okay, so hopefully when you solved it, you should get these answers. So number 1, the sodium hydroxide, the molar mass was 40 grams. Okay. Number 2, you should have calculated that the molar mass of number 2 was 110 grams. For number 3, it's 27 grams, and number 4 was 46 grams when you total them all up. I saved number 5 to do together. It's a little more complicated, so let's look at it. We've got calcium, and if you look up calcium on the periodic table, it's right here. Okay, it has the molar mass of 40. But how many do we have, guys? We have 3 of them, right? So there's 3 calciums. So what's 40 times 3? 120. Okay. We've got phosphorus. Phosphorus on the periodic table is over here. If you look at that number, phosphorus is 30. What does that round to? 30.97. 31. But how many phosphorus atoms do we have right here, guys? This 2 gets, remember, you got to distribute that, and it times it by the existing subscript. So what's 2 times 1? Well, it's 2. So 31 times 2 is what? 62? Okay. And we have oxygens. Oxygen on the periodic table is over here. If you look up its molar mass there, it's 16. It rounds to 16. How many oxygens do we have, guys? 6. Okay, so we can't forget to do that. So 16 times 6. Did you guys get 96? Okay. Then we have to add all of those numbers together. So 96 plus 62 plus 120. Did you guys get 278? And hopefully, who else got that? Anyone get it? Okay. So it seems like that's the right molar mass for this compound. Calcium phosphate. Hey, are we confident with molar mass? Can we calculate them now? Even for large compounds like this one, it takes a little bit of time, but we know how to do it, right? Just use the periodic table. What I would say, guys, is round to the nearest whole number. Okay, always round to the nearest whole number. Let me go through some examples of that. Strontium, if you look on the periodic table, is 87.6. What would I write down for the molar mass? Well, that rounds to 88. Okay. What about magnesium, which is 24.3? What does that round to? 24. Just round to the nearest whole number. Now, realize, will your answer be as precise if you round? It won't. So, but it does kind of simplify all of our calculations. We don't have to deal with decimals. But it won't be as precise. So, all right, here's the skill that we're going to learn today. We're going to use this roadmap, and we're going to learn how to go from moles to mass, to grams. Okay? When we do that, so if you're at moles, we're going to go over here to grams. We're going to take this bridge across here. We need to times by this top conversion factor. So let's do a few practice problems where we do that. Okay, practice problem number 11. We're going to still follow the same 3 rules that we learned in the last video, how we did it last time. Okay? It says you're working in a chemistry lab, and the reaction calls for 3 moles of copper. How would you measure that amount? Because when you go to the scale and you have your copper there, it doesn't say moles, does it? What does it say, the scale? Grams. It says grams. So we need to convert 3 moles of copper to grams. That's what we need to do. So what's step number 1? What do we underline here, guys? What they give us, 3 moles of copper. We're going to circle what they want us to go to. What is it in this problem? How would you measure that amount? Grams. So we're going to go to grams. Circle it. Okay. Now step 2. What do we do? Write down what they gave us, which was 3 moles of Cu. and put it over 1. Okay, that's step 2. Step 3 is to go to the road map. Where are we right now? Well, it says we're at 3 moles of copper, so we're right here. Here we are in the moles box. Where do we want to go? Well, we want to be able to measure it on a scale, so we got to go to grams, which is over here. Okay, let's map this out. Which bridge should I cross? Yeah, the one that goes in that direction, right? So we're going to times it by this conversion factor. So let's do that now. Okay, we make a new conversion factor here. It says that molar mass goes on top and 1 mole goes on the bottom. So I'm going to write 1 mole. Now, what substance are we talking about in this problem? Copper. So 1 mole of copper goes on bottom. Yeah, guys, whatever goes here, whatever's on top has got to go on the bottom. Okay, now molar mass. What is it talking about?
How much molar mass is in copper?
In copper, good. So if you look up copper on the periodic table, it's right here. I want the number that it gives. Rounded to the nearest whole number is 64. Good. So 64. 64 what? Grams. Don't forget to put the unit. And the substance. What? 64 grams of what? We're talking about copper. Okay. Now let's cancel out our units. Moles of copper cancels out. So I'd like to see you cross those out. Moles of copper divided by moles of copper is 1. They cancel out. I'm left with grams of copper in terms of the units. So can I stop there? Yes, because I wanted to go to grams. So let's, now it's just a math problem. What's 3 times 64? Good, 192? 192. And 1 times 1 on the bottom is just 1, right? So I mean, you could put it divided by 1, but we know that that's just going to equal itself 192. Can I just circle that and be done? Good, you got to include the units, which is in right here. So grams of copper. Okay, and this problem does a good job of illustrating why this is important. If we're doing a lab and I say get 3 moles of copper, now you will know how to figure out the measurement for that, right? You're going to have to do this conversion. You're going to figure out that it's 192 grams. You can go over to the balance there, put on the copper until it says 192 grams, and you know that that is 3 moles of copper. Correct?
Yes.
Good. Okay. So I got that 191. Yeah, we rounded on our molar mass, so we're less precise, but as long as you're close with your answers, if it's just a rounding issue, I will give you credit. Okay, practice problem number 12 I want you to do on your own. Okay, try it. If you're watching the video, please try it. So hit pause right now and try it first. Okay, let's go through this one. So hopefully you underlined 18.2 grams of lithium because that's what they gave us. So the rest of step 1, you're also supposed to circle what you're supposed to go to. We want to convert that 18.2 grams of lithium to moles of lithium. That's step 1. Step 2, we're going to write down what they gave us, which was 18.2 grams of lithium. I'm going to abbreviate lithium by Li. That's its symbol. Put it over 1. Why do we do this step? Well, it helps us line up our conversion factors later on. Okay. Step 3, where are we on the roadmap? So we come down here to the roadmap. Where are we at right now, guys? We're at grams. So here you are. Where do you need to go? We circled moles. So let's come over here to moles. That's our destination. How do we get there? Follow the arrows. Okay? You're going to times that number by this conversion factor then. So let's do that now. Okay, so I add that new conversion factor in. It says that 1 mole is on top. So I'm going to put that. And the molar mass is on bottom. But it doesn't tell me what molar mass you're talking about because every problem is going to be different. So what substance are we talking about here? Lithium. But here's an easy way to determine that. whatever you start with, whatever is here needs to come down here. So grams of lithium. What is the molar mass for lithium? Well, look on the periodic table right there, and it rounds to what, guys? 7. 7 grams of lithium in 1 mole of what? Of lithium. So please put the substance in there. Now let's cancel out units. Grams of lithium divided by grams of lithium is 1. It cancels out. So strike that. What units are we left with here is moles of lithium. Well, look, that matches what we wanted to go to. So I can stop there, throw on your equal sign. Now it's a math problem. We take everything on the top, times them together. 18.2 times 1 is 18.2. On the bottom, we got 1 times 7, which is 7. Okay? Let's put that in your calculator. 18.2 divided by 7. Did you guys get 2.6? Huh?
Yeah.
Can I just circle and be done?
No.
Nope. 2.6 what? Moles of Li, or moles of lithium. Okay? You've got to tell people what you're talking about. Okay, how many of you guys got number 12 right? Good job. Hey, this is easy, right? This is easy stuff. I've got a lot more practice problems to go through, so let's do that. Just to make sure that we got it down. I created this fancy PowerPoint, and look, I don't even use it. And sounds. Still don't even use it. Okay, we're 13. Let's read it. It says, how many grams of lithium are in 3.5 moles of lithium? I would like you to try this one on your own. So if you're watching the video, please hit pause right now. Try it. Once you have an answer, hit play and see if you got it right. Okay, so I went ahead and solved this problem. If you're following along at home on the video, hopefully your paper looks like this one, okay? You underline what they gave you. You circled where we're going. You wrote down what they gave us over 1. Then you went to the roadmap down here. You realized that we have moles. It gave us moles, so you're here. We want to go to grams. You circled that. So I put a star here. Let's map it out. You come across this top ridge. That means we're going to times by molar mass over 1 mole. And why we do that is try to get moles to cancel out. We're converting units here. We want to go to grams, so we've got to get our moles to cancel out. You've got to put it on the bottom here. We'll go to grams. Now it's a math problem. 3.5 times 7 is 24.5. 1 times 1 is 1. So hopefully you got 24.5 grams of lithium. How many of you guys got that? Okay, good job. Let's go to 14. Let's do the same thing. Oh.
What time do we get out of this class?
Hey guys, did you guys get 24.5?
Yeah.
Yeah, that's got to be a wrong answer here, huh? Okay. Okay, practice problem number 14. Again, I want you guys to try this one on your own. I'm going to go through and solve it, so please hit pause right now and see if you can do it on your own first. Okay, so let's see how you did. Hopefully your paper looks like this one. Okay, you have underlined what they gave us, circled grams of chromium, that's what we're supposed to go to. You put down what they gave you over 1. You've gone to the roadmap, we're at moles, trying to go to grams, so you followed the path, timesing it by this conversion factor, so that's why I have molar mass, which was 52 grams for chromium. You can figure that out right here. Over 1 mole of chromium. Your moles of chromium cancel out. And when you times that through, you should get 2.34 grams of chromium. Okay. Okay, so let's go to practice problem. Let's go to the next one. Okay, I don't think we need to do the extra problems. Okay, now that we're going to switch things up, we're going to go from moles to mass for compounds. So we're going to go from here, we're moles, and we're going to go to mass, but it's going to be for compounds. Okay, so again, we're going to do the same thing. We're going to come across, times it by this. and we'll be there. Practice problem 15. Let me go through this one with you. Okay, it says, what is the mass of 2.5 moles of this molecule here? Okay, so let's underline what they give us, and let's circle what they want us to find. They want us to find the mass of it. Step 2, we're going to write down what they gave us, 2.5 moles of this compound. And put it over 1. Okay. That's step 2. Step 3, now let's go to the roadmap. We're at moles, so here we are. And it wants us to know to convert that to the mass. And so we need to come over here to mass in grams. So let's take the right bridge here, which is this top one. That means we're going to times it by this next conversion factor right there. Okay, so let's do that. Okay, it says 1 mole is on the bottom, so I'm going to put 1 mole down here. The substance that we're talking about in this problem is C3H5S. And it says that molar mass goes on top. So we need to calculate the molar mass. Carbon, which is right here, has the molar mass of 12 if you round it. But how many carbons do we have? Well, we've got 3 of them, so I'm going to times that by 3. And that's 36. Okay, let's go to hydrogens. Okay, we've got hydrogen. Hydrogen is right here. Its molar mass is 1, but I've got 5 of them. So I'm going to times that by 5. That gives me 5. And I've got sulfur. Sulfur on the periodic table is right here. Its molar mass is 32. And I've only got 1 sulfur, so I'm just going to times it by 1, so that's 32. Now when we add that together, 36 plus 5 plus 32 is 73. So it has the molar mass of 73 grams. I'm going to put that in like it says on the top here, so 73 grams goes in on top. And I'm going to put what substance we're talking about, C3H5S. Okay, now let's cancel out like units. My moles of that compound cancel out, and I'm left with grams of that, which is the mass. So I can stop there. Let's do the math of this problem. 2.5 times 73 is 182.5. And 1 times 1 is 1, so I'm just going to keep it as that. And now my units is going to be grams of C3H5S. Okay. And so that's how you will work a problem with a compound or a molecule in it. You just have to add up the molar mass and put it in there for the molar mass. So basically, it's the same thing. Okay, I've got one more practice problem for this video. Practice problem number 16. Let me go through it with you. It says, calculate the number of moles of calcium hydroxide in 325 grams of the compound. Okay, they're giving us 325 grams. It wants us to calculate the number of moles. So I'm going to circle that. Okay. What makes this problem a little different is it doesn't give us the formula for calcium hydroxide, but in this point in the class you should be able to do the crisscross method and come up with a formula. Calcium, which sits right here, has a charge of +2. So I'm going to put +2 right here. Hydroxide is a polyatomic ion. Hydroxide is OH and it has a -1 charge. So I'm going to put a -1 right there, crisscross it. The Ca, the 1 comes down, so I don't need to write it. Hydroxide is OH, and the 2 needs to come on the outside of the parentheses. Okay. All right, let's go to step 2, which says to put what they gave you, 325 grams. of CaOH2 over 1. Step 3, let's go to the road map. Okay, we are at grams. So I'm right here now, and I need to go to moles. Oh, whoops, so we're at grams, so here's U. And I need to go to moles. So now let's map that out. We're going to take this bottom bridge across, because that one's pointing in the right direction. That means I'm going to times it by that conversion factor. So let's put that on. It says that 1 mole goes on top, and the molar mass goes on the bottom. We need to calculate the molar mass. Calcium. If you look it up, it's right here. Has the molar mass of 40. I've just got 1 calcium, so that's it. I've got oxygens. Oxygen is right here. Its molar mass is 16. But how many oxygens do I have? You take the number on the outside and times it by the subscript, which is 2 times 1 is 2, right? So 16 times 2 is 32, right? And we've got hydrogens. Hydrogen is right here. Its molar mass is 1. But how many do I have? 2. So a total of 2 there. So what is that, guys? So 74? Is that right? So 74 is my molar mass, 74 grams of CaOH2. And I'm going to put the substance that we're talking about on top as well. 1 mole of calcium hydroxide goes on top. Okay, now I can cancel out like units. Grams of calcium hydroxide is canceled out. And I'm left with moles of calcium hydroxide, which is what we wanted to find. So I'm finished. Now it's just a math problem, right? So grab a calculator. And we're going to do 325 times 1 is 325 on top. And on bottom it's 1 times 74. So 74 goes on bottom. When you divide those two numbers, I'm getting 4.39. 4.39, and you got to include the units, which is moles of calcium hydroxide. Okay. And that's it for this video. So hopefully that makes sense. Finding molar mass really isn't that hard. We use the periodic table to do that. And again, we're just going to round it to the nearest whole number when we get it off the periodic table. And the rest of it's the same as we've been practicing in the previous videos. So nothing new really other than molar mass. So hopefully you understand how to do this part of the roadmap now. Okay, before we end the video though, I wanted to give you some more practice. So in your student workbook, there's a worksheet. It's titled Molar Mass and Mole to Mass Conversion Worksheet. Again, it's called Molar Mass and Mole to Mass Conversion Worksheet. Please go there now and give yourself some more practice with these types of problems, and hopefully that helped.